Welcome back, learners. This is episode 8 of our Neet Chemistry series for 2025 and 2026. I'm your mentor, Sir Chong Tham David, and today we are exploring the intriguing world of DNF block elements, vital topics that reveal the unique behavior of transition and inner transition metals. We'll work through 45 carefully chosen questions to help you master concepts like electronic configuration, complex formation, and magnetic properties. Just as electrons in DNF orbitals have unique properties, your consistent effort and focus will define your path to success. Remember, in the complex world of elements, true strength lies in mastering the details. Now let's dive deep and unlock the secrets of chemistry together. Let us read the questions. Question number one: which one of the elements with the following outer orbital configuration may exhibit the largest number of oxidation states? So, given to you, you have 3d5 for S1, 3d5 for S2, 3d5, 3d2 for S2, and 3d3 for S2 configuration. So, if you write the configuration for these elements, we'll take manganese. It has 3d5 for S2 configuration, and the number of oxidation states which are possible are plus 2, plus 3, plus 4, 5, 6, and 7. So B will be the answer. The elements that shows the maximum oxidation number will be manganese. Let us move on to question number 2. The addition of excess of aqueous nitric acid to a solution containing copper salt solution produces. It would be tetrahydroxy copper 2 ion. B will be the answer for question number 2. I hope it is understood. Let us again read question number 3. The spin only magnetic moment of nickel 2 plus in aqueous solution would be. Now the number of unpaired electrons in nickel 2 plus equals to 2. So water is a weak ligand, hence no pairing will take place, and the spin magnetic moment can be calculated from the formula mu equals to root over n plus 2. Now the unpaired electrons equals to 2. So if n equals to 2, 4 2 is 8, and you know root 8 is equals to 2 root 2, and you know the value of root 2 is 1.414, the answer would be 2.82 Bohr magneton. Okay, question number 4. Let us read. In the form of dichromate, it is a strong oxidizing agent in acidic medium, but molybdenum 6 in molybdenum trioxide, tungsten 6 in tungsten trioxide are not. Okay, the options are because chromium 6 is more stable than molybdenum 6 and tungsten 6. Molybdenum 6 and tungsten 6 are more stable than chromium 6. Higher the oxidation state of heavier members of group 6 of transition series are more stable. Lower oxidation states of heavier members of group 6 of the transition series are more stable. So question number 5, question number 4, you're asked in the form of dichromate, chromium 6 is the strongest oxidizing agent in acidic medium, but not molybdenum and tungsten. So the reason for this question number 4 would be, it would be both these two, that is molybdenum 6 and tungsten 6 are more stable than chromium 6, and higher the oxidation state of heavier member of group 6 of the transition series are more stable. So 2 and 3 are correct. Then the option would be B for question number 4. Moving on to question number 5. Of the following outer electronic configurations of atoms, the highest oxidation state is achieved by which of the following you're given different types of configuration. You're asked to find the highest oxidation state. So N minus 1 D 5 NS2 would exhibit the maximum oxidation state of plus 7. Okay, so 5 would be question number 5. Answer would be option 2. Question number 6. N minus 1 D10, that is penultimate D electrons, NS2 valence electron. This is the general electronic configuration of. This is the configuration of pseudo transition elements, that is zinc, cadmium, and mercury. Great. Let's read question number 7. In the following salts, the highest value of magnetic moment is observed in which of the following hydrated salts? See, in manganese 2 plus, there are 3d5, that is no unpaired electron. 5. Copper 2 plus, there are 3d9, that is number of unpaired electron equals to 1. Iron 2 plus, 3d6 configuration, that is the number of unpaired electron would be 4. Zinc 2 plus, there are 3d10 configuration, number of unpaired electron is equals to 0. Nickel 2 plus, it is 3d8 configuration, that is number of unpaired electron equals to 3. So higher the number of unpaired electrons, higher will be the magnetic moment. Hence, manganese 2 plus having maximum unpaired electrons will have the maximum magnetic moment. So answer to question number 7 would be A. See, from this train, what can you conclude, my dear students? You can see questions are asked mainly on the oxidation state, maximum, minimum. Manganese is one of the commonly asked questions. Now let us see question number 8. Which one of the following transition metal ions shows magnetic moment of 5.92 Bohr magneton? So given magnetic moment of transition metal is, so what is the Bohr magneton value of N plus 2? This is already given in the question, 5.92. You need to decode the value of N. So N must be 5 because this 5.92, 7 5 is 35. What is root over 35? This is 5.92. So how do you get this 35? When N equals to 5. And put this value of N equals to 5 in this equation, you will get the square root of 35, that is 5.92. Since N equals to 5, number of unpaired electrons in manganese 2 plus would be 5 number of unpaired electrons, whereas in the case of the remaining ions, titanium 1, chromium 3 plus 3, copper 2 plus 1, cobalt 2 plus would be 3. So manganese 2 plus have the maximum magnetic moment 5.92. So unpaired electrons 5. This question number 8, the answer would be option A. I hope it is understood. Let us move on to question number 9. Read the statement. Which of the following statement is incorrect? Zinc, cadmium, mercury, due to presence of completely filled d orbitals, are not studied along with other transition metals. Zinc, cadmium, and mercury have low melting point and are comparatively softer than other transition metals. Metallic bond made by elements with D5 configuration is stronger as compared to metallic bond made by elements with D3 configuration. Metals of 5D series form strong metallic bonds as compared with metals of 3D series. So zinc, cadmium, and mercury, due to the presence of completely filled d orbitals in the ground state as well as in their common oxidation states, are not regarded as transition metals, but they are studied along with the transition metals. So zinc, cadmium, mercury, due to the presence of completely filled d orbitals, that is n-1 d10 ns2 configuration, are not studied along with the transition metals. They are also termed as the pseudo transition elements. Superconductors are, question number 10, are derived from compounds of transition elements. Superconductors are derived from compounds of transition elements. Option D is the answer to question number 10. Let's read question number 11. Which of the following compounds has color but not unpaired electrons? You're given different types of oxides of potassium, permanganate, potassium manganate, manganese sulfate, manganese dichloride. The electronic configuration of manganese is argon 3d5 4s2 because the atomic number is 25. Before iron, manganese comes, and after chromium, manganese comes. 25 is the atomic number. Configuration would be argon 3d5 4s2. Being transition metal, it has 7 valence electrons and all are involved in bond formation. In the case of potassium permanganate or after in the solution, it exists as permanganate ion. Hence, it has no unpaired electrons. So answer to question number 11 would be KMnO4 is the answer, and it is the compound which has color but no unpaired electrons. You know the color solution is purple. Next, 12. What is the percentage of lanthanoid metal in mixed metal? The mixed metal consists of a lanthanoid metal. It comprises 95% of the lanthanoid element and iron 5% and traces of sulfur, carbon, calcium and aluminium. So 12 answer would be D. Okay, mixed metal comprises, I'll repeat, 95% lanthanide elements and only 5% approximately, okay, iron. And some traces may be present if it is not completely filled to 100% traces like sulfur, carbon, aluminium, calcium. Let us move on to question number 13. Which of the following in its oxidation state shows paramagnetism? Terbium, lutetium, cobalt, lanthanum 3, etc. So terbium in the configuration 4 plus, that is after losing 4 electron terbium, it will have, after losing 4 electrons, it has the configuration 4f7 with how many unpaired electrons? 3. 3 unpaired electrons. In the case of lutetium, 3 plus, it is in the configuration of 4f14. So 0 unpaired electrons. Similarly for, this is cerium, okay, not cobalt. Cerium 4 plus, configuration would be 4f0. So 0 unpaired electrons. Lanthanum 4f0. 0 unpaired electrons. So in this case, terbium would show oxidation state for F7 is the configuration. It has 3 unpaired electron. Since there are 3 unpaired electron, it would show paramagnetism. Clear? Let's read question number 14. In neutral or faintly alkaline medium, thiosulfate is quantitatively oxidized by potassium permanganate to which of the following sulfur oxides? Say in neutral or faintly alkaline medium, thiosulfate is quantitatively oxidized by potassium permanganate to sulfate ion. Answer would be option B. You can give the reasoning by writing the chemical equation. KMnO4 reacts with thiosulfate. It has the formula Na2S2O3, water molecule. Then you identify the product. Potassium sulfate MnO2, manganese dioxide, sodium sulfate, and potassium hydroxide. So there are already 8 here. So how many you have to put here? 3 to the 6. You can balance this 8. And for sodium, you put it 3. Now it is balanced. So ultimate product would be sulfate. Now let's read question number 15. Wrought iron, pig iron, and steel differ in the properties due to, see, they contain different percentage of carbon. So carbon contained would be the answer for question number 15, option A. 16. The lanthanide contraction is responsible for the fact that in vertical columns of transition elements, there is an increase in the size from first member to the second member as expected. But from the second member to the third member, there is very small change in size, and sometimes the size are same. So this is due to lanthanide contraction, and this is the reason for zirconium and hafnium to have the same atomic radius. So B, zirconium and hafnium have the same radius is the reason, is the answer for question number 16. Question number 17. Potassium permanganate can be prepared from potassium manganate as per the reaction. You are given this ionic equation. Now the reaction can go to completion by removing this hydroxide ion by adding. See, high Cl and sulfur dioxide are reducing agents and can reduce permanganate. Carbon dioxide, which is neither oxidizing nor reducing, will provide only acidic medium, and hence it can save the reaction in the forward direction and the reaction can go to completion. So 17 answer would be option B. Next, question number 18. On the basis of the data given to you, scandium ion, chromium ion, manganese ion, copper ion, which of the following statement is incorrect? Okay, manganese, Mn2 plus, it has D5 configuration and more stable than Mn3 plus, which has D4 configuration. Thus, this Mn3 plus will be positive. And this statement number B will be the incorrect statement. Mn3 plus is more stable than Mn2 plus is the incorrect statement. So B is the answer, the option 4, question number 18. Question number 19, green vitriol is iron sulfate, 7 water molecule, option A. Question number 20, the number of moles of potassium dichromate reduced by 1 mole of tin ion is. So to answer this question, you have to write down the reaction first. Potassium dichromate generates this dichromate ion, and after gaining these 6 electrons, dichromate ion will subsequently be changed to, in the acidic medium, it will change to chromium and balance this with water molecule. So there are 2 chromiums, put here 2 to balance this hydrogen 7, 14. And in the second case, tin, it is going to undergo oxidation by losing electrons, 4 plus 2 electrons. Okay, that means 1 mole of tin 2 plus provides 2 mole of electrons, which will reduce 1 by third of Cr2O7, 2 minus. So the answer for this question would be A. Moving on to question number 21. 4 successive members of the first series of the transition metals are listed below, for which one of them the standard potential value has a positive sign: cobalt, nickel, copper, and iron. Now, if you look at the SRP values of copper, cobalt, nickel, and iron, you have to Keep in mind the SRP values of copper is plus 0.34. The standard reduction potential for copper is 0.34 and has a negative reduction potential. Whereas for cobalt, 2 plus, it has 0.28 volt. And for nickel, I'm going to write here for short, minus 0.25 volt. And iron, it is minus 0.44. So looking at these SRP values, you can conclude that iron, copper, nickel, and cobalt, these are the SRP values which I've shown you here. Which of them have the standard potential value as positive? So you can see that copper has positive potential values. The answer for question 21 is option C. I hope it's understood. Let's read question number 22. Which of the following factors may be regarded as the main cause of lanthanoid contraction? So read the statement. In the lanthanides, there is polar shielding of 5d electrons by 4f electrons, resulting in greater attraction of the nucleus over the 5d electrons and contraction of the atomic radii. So, pore shielding effect of the 5d by 4f electrons. So, this answer would be option B. 22B. 23. Silver chloride is soluble in ammonium hydroxide solution. The solubility is due to the formation of. See, when silver chloride is added with ammonium hydroxide, it generates ammonium salt, diamino, silver chloride, and water molecules. So 23 would be, it would be silver salt. Option C is the answer. Question number 24. Oxidation states of the metal in the minerals hematite and magnetite respectively are 2, 3 in hematite and 3 in magnetite and so on. Read the statements and answer the question. 2, 3 in hematite and 2 in magnetite, 2 in hematite and 2, 3 in magnetite, 3 in hematite and 2, 3 in magnetite, 3 in hematite and 2, 3 in magnetite. The hematite is actually ferric oxide in which iron is in +3 oxidation state. Magnetite is an equimolar mixture of ferrous oxide and iron trioxide. So the oxidation states are in two different forms. So what is the answer to this question? 24 would be 3 in hematite and 2, 3 in magnetite is the answer to question number 24. Question number 25, let's read. In which of the following in acidic medium potassium permanganate oxidized iron sulfate solution? Which of the following statement is correct? The 1 molar of potassium permanganate equals 2 equivalents 5 normality of potassium permanganate and against equals 5 normal of iron sulfate. You know the relationship between molarity and normality, right? See, normality equals to n factor into molarity. That you have to keep in mind, and then you can rewrite this. I will write it here. 1 molar potassium sulfate. Potassium, no, it's given potassium permanganate, right? Erase this. 1 molar KMnO4 equivalents 5 normal potassium permanganate. Because molarity and normality is related as normality equals to molarity into n factor, which again equals to 5 normal iron sulfate. So given to you here, from this you can conclude 10 into 1 molarity. And for this, you can write 10 into 5. And for this, you have 5 into 10. So answer would be 10 ml of 1 molar KMnO4 solution oxidized 10 molar 10 ml of 5 normal iron sulfate solution. The relation is very simple. Normality is equals to n factor. Just find out the n factor and then multiply with the given molarity. So question number 25 would be option B. I hope it's understood. Let's read question number 26. In which of the following lanthanides oxidation state plus 2 is more stable? So europium has electronic configuration Genin 4F7. So answer for question number 26 would be B. Acidified solution of chromic acid on treatment with peroxide gives blue color. It is due to, see, when you write the reaction, you can find out that this chromic acid undergoing oxidation, H2Cr2O7 plus, this is nascent oxygen, it gives a blue peroxide of chromium plus water molecule. So the answer for question number 27 would be B. This is blue in color. This one. Okay. Question number 28. Which of the following is used in the preparation of chlorine? 28. Both manganese dioxide and potassium permanganate are used for the preparation of chlorine by the addition of concentrated HCl. 28 would be C. 29. An explosion takes place when concentrated sulfuric acid is added to KMnO, for which of the following is formed? An explosion would be, okay. To answer this, let's write the equation. KMnO4 treated with sulfuric acid. This should be concentrated. Now you're given this reactants. The product that would be formed are Mn2O7. See, this is very explosive in nature. And one more product, water molecule. So answer would be option A. Let's read question number 30. Which of the following statements are correct? Chromium has the highest melting point among the series of series 1 metals. Number of unpaired electrons is greater in chromium than other elements of series 1. In any row, the melting point of transition metal increases as the atomic number increases. So find the following statements which are correct. 30. So in any row, the melting points of transition metal rise to a maximum of D5 except for anomalous values of manganese and technetium and falls regularly as the atomic number increases. So one is the correct answer. 2 is also correct. That means if 1 and 2 are correct, option B is the answer for question number 30. Moving on to question number 31. In the laboratory, manganese 2 salt is oxidized to permanganate ion in aqueous solution by, okay, in laboratory, manganese 2 salt ion is oxidized to permanganate ion in aqueous solution by peroxodisulfate. This is the answer for question number 31. You know the formula of peroxodisulfate, S2OA2 minus. Okay, question number 32. Which of the following statements about the interstitial compounds is correct? Incorrect. Interstitial compounds, small atoms like hydrogen, boron, and carbon, enter into the void sites between the packed atoms of crystalline metal, and they retain metallic conductivity and are chemically inert. So 2032 would be A. Okay, they're chemically inert is the answer to question number 32. Let's read question number 33. Which of the following elements shows maximum number of different oxidation state in its compounds? Europium, lead, gadolinium, americium. So 33, europium has plus 2 and plus 3. Lanthanum has plus 3. Gadolinium has plus 3. Americium plus 4 plus 5 plus 6. Even up to the extent of plus 6. So 33, answer D. 34. Identify the product and its color when manganese dioxide is fused with solid potassium hydroxide in the presence of oxygen. So question number 34, there will be formation of a dark green mass when this potassium hydroxide reacts with manganese dioxide. We also call this the pyrolusite ore. Okay, oxidation. It gives rise to a dark green mass. Call it K2MnO4. So this is a dark green mass. The answer for question 34 would be B. Let us read question number 35. In this extraction of silver from argentite ore, the ore is treated with dilute solution of sodium cyanide in water in the presence of Y, whereby the following reaction takes place. X and Y in this reaction are respectively. So silvers, okay, in this reaction, we can account silver sulfide reacts with the sodium cyanide and oxygen. So the complex compound would be sodium dicyanoargentate. This is your argentite ore, and with the formation of product sodium sulfate. So 35 would be sulfur and oxygen. X is sulfur, okay, and Y will be oxygen. This X is sulfur, I have shown you here, right? And Y will be oxygen. So option B is the answer to question number 35. Moving on to question number 36. Which of the following compound is called Turnbull's blue? Ferrous cyanide is known as Turnbull's blue. Question number 36. Option B is the answer. 37. Which of the following element is responsible for oxidation of water to oxygen molecule in the biological process? So oxidation of water takes place in the presence of manganese in the biological process. So B is the answer to question 37. 38. Consider the following statements. Lanthanum hydroxide is the least basic among hydroxides of lanthanides. Zirconium, hafnium possess almost the same ionic radii. Cerium can act as an oxidizing agent. Which of the above is true? So as a result of lanthanide contraction, zirconium and hafnium possess almost the same ionic radii. Cerium is an oxidizing agent. Cerium 4 plus gains electrons to acquire more stable cerium 3 plus. So lanthanum hydroxide should be the most basic among the lanthanide hydroxides. So comparing this, you can get 2 and 3. This would be the answer to question number 38. These are the statements which are true. Zirconium and hafnium possess almost the same ionic radii. Cerium can act as an oxidizing agent. For making silver from silver nitrate, which of the following is used? 39. So when silver nitrate reacts with phosphine, then silver is formed. So how does it take place? Let us read. Let us write the reaction. When the silver nitrate is treated with a phosphine, you know, these are the hydrides of group number 15. You have nitrogen forming hydride, ammonia, phosphine, arsine, stibine, bismuthine. Now, phosphine is the group 15 hydride. It is a pungent smelling nicogen, nicomides, you can say. Anyway, when this reacts with the silver nitrate, there is formation of silver and acid, phosphorus acid, and nitrogen dioxide. So 39 would be phosphine. Phosphine is the answer to question number 39. Let us read question number 40. Which of the following conversion can be carried out by both acidified potassium chromate and acidified potassium permanganate? Iodide is converted to iodate by neutral or faintly alkaline permanganate ion. I can show you this reaction here. If you write down the reaction, KMnO4 generates MnO4 minus, and water is required for this reaction. It gives pyrolusite or MnO2, hydroxide ion, and iodide. Okay, so from this you can see that you can balance it later on. One would be correct? It undergoes oxidation. Three, this is also increase in the uh, oxidation state, that is oxidation from this hydrogen sulfide to sulfur. It is also increase in oxidation numbers of oxidation. So 1, 3, and 4 would be the answer to question number 40. You know how to calculate oxidation number, right? Okay. Question number 41. The catalytic activity of transition metals and their compound is mainly due to. It is mainly due to C. The transition metals and their compounds are used as catalysts because of the ability to show variable oxidation state, which is one character for deep block elements. They can form intermediate compound with one of the reactants. This intermediate provides a new path with low activation energy. So suppose you have divanadium pentoxide from the transition metal first 3D series. If they react with sulfur dioxide, it forms divanadium tetraoxide and sulfur trioxide. And if it further undergo reaction with oxygen again, it goes back and form divanadium pentoxide. So C, it can have the ability to adopt variable oxidation state. This is the answer. One main reason why they show catalytic ability is ability to show variable oxidation state. Question number 42. Let us match the column. Okay. Metal of the 3D series which does not form metal oxide MO type would be scandium. Metal of the 3D series which form most covalent oxide would be manganese. Metal of the 3D series which forms amphoteric would be vanadium. So B is the answer to question number 42. Let's read question number 43. The basic character of the transition metal monoxides follows the order. Okay, you're given the atomic number titanium, vanadium, chromium, manganese 22, 23, 24, and 26. Their oxides and their basic character. So this is the question. So the basic character of the transition metal monoxide would be titanium oxide, vanadium oxide, chromium oxide, iron oxide. This would be the train. So A would be the answer to question number 43. The reason being because the basic character of oxides decrease with the increase in the atomic number. Oxides of the transition metals in low oxidation state, that is plus 2 and plus 3, are generally basic except for chromium oxide. I hope it's understood. Let's read question number 44. The excited state of configuration of manganese 2 plus is. See, after crystal field splitting, the 5D orbitals get separated as 3T2 and 2,4 orbitals. For manganese 2 plus, the last cell has 5 electrons, that is 3D54S0. So by obeying the Hund's rule of maximum multiplicity, the excited state configuration would be 3 2 T T2G 3 electrons, and the EG there would be 5 2 electrons. So in total 5 electrons, right? So manganese 2 plus is, it would be showing T2G3 EG2. 44 is D. Okay, as usual, the last question would be is going to be solved by you. You can answer this question in the comment section, and we shall see in the next class. Thank you.